Okay guys, today we're going to do the next two problems in your project examples, which is 7 and 8. So these are examples to help you out with project number 7 and 8. So earlier you did 1 through 6 with linear, now we got quadratics and exponential. So these aren't going to be too bad. Most of it's in a calculator, but you just have to know where to stop and where to begin and everything. So a flare is shot in the air. Its height is modeled by this. So I already give it to you, where y is the height and x is the feet in seconds. So this is height. I didn't label it before. It should be. And then this is feet. I'm sorry. My fault. Sorry about that. That's time. Okay, in seconds. All right, so what we're going to do, we're just immediately going to go to the calculator, and we're going to get this table. We need a table here to plot these points, and we're going to need these intercepts and everything. So let's go to our calculator and type in negative 16x squared plus 96x minus 80. Now you can graph it if you want to, but to be honest, you're just going to really want the table. And you're going to want lots of zeros and numbers and stuff. So if you look here, you see these. I really wish I could write on this, but so you see these numbers here: 10, 248, 364. All right, these are the ones you're going to want to write down. All right. So I'm going to have to go back and forth because 1, 0, 248, 364, sorry, 448, and 50. That's really all you're going to need. If you look here, there's no decimals that you need. But once you get to 0, if you kind of think about the scenario, sorry about that. If you look about the scenario, if this is the height of something, right, this is the ground. So that means once it's launched, that it's going to hit the ground. So all I really need to do is plot these points. So I'm going to change colors so you can see what I'm doing here. Here's 1, 0. Here's 2, and the best I can, 48. Okay, it's the best I can do. 364. All right, 445. I'm sorry, that's 48. Of course, it's 48, right? And 50. So here's your quadratic upside down, and that's all that matters in this scenario, right? We're talking about just the scenario. So anything down here doesn't matter because the ground stops the flare. All right. So I did it again where I drew the graph for you so it looks nice and pretty. And then we need to answer these questions. All right. So hopefully this graph is where you graphed it. I'll see if I can remember again to attach the notes for you. And now we have to answer these questions. So it says, what is the domain? Well, if you look at the graph, the domain goes from left to right. Well, the left side of the graph is right here. This is where it starts, right? And the right side, let me change colors here. The left side starts here and the right side starts here. So what is it? It's between 1 and 5. So that's what you're going to write. You're going to write that compound inequality again, where it's between 1 and 5. All right, so 1 less than or equal to x less than or equal to 5. Now go back to the calculator, look for the y's. Again, domain is x, range is y's. All right, so I'll write that again, even though you should have wrote it down last notes. All right, let's go back and look at the y's. All right, y's go from here, which is, again, 0, and all the way to this very, very top. Well, if we go one step backwards, which is the height, is the biggest height, and we know that the top is 64 right there. All right, so it's between 0 and 64. So the flare in this situation goes from 0 to 64. 0 less than or equal to x less than or equal to 64. What is the x-intercepts? Well, we can see them here. They are 1, 0, and 5, 0. And it's it'll say, what does it represent? I'm sorry, that should say, what does it represent? Does it not? I guess not. Okay. Oh, that's minimum, maximum. I'm sorry. And then the y-intercept, if you go look real quick, because we can't see it on the graph. You see it's not there? So we have to look at our calculator to see what the y-intercept is. So I'm going to look And there it is right there. I just highlighted it. It's 0, -80. We didn't need to write that down because it wasn't in our scenario. It's 0, -80. It doesn't matter, but it is the actual y-intercept. So 0, -80. Okay, it says, what is the minimum of this graph? And we all know it's been 0. So the minimum is 0. And it says, what does this represent? Well, that's literally the ground, right? So you could say that, you know, the height is 0 if you want, but that's the ground. And it says, what is the maximum? The maximum is 64. Oops, that looks like a 9. Is that right? Give me a sec. All right. The max is 64. So what is that? Well, if you think about something that gets launched in the air and then turns and falls to the ground, that's maximum height of the flare. All right. And that's how you do quadratics in that case, okay? So that's really all it is in quadratics. The very important part is looking at this graph and seeing where the low part, the high parts, you got the low parts, the high parts, and what it goes from, okay? All right. Exponential is a little different. Exponential kind of has this ongoing situation, and that's what gets a little tough about it, okay? So let's look at this situation. In 2020, the population of small town is 3,000. Again, I made this up because I just wanted to show you. I just didn't want to get too big of numbers either. So it is decreasing by 9% each year. The population is modeled. So here, right, there's your model of something decreasing. Of course, you should realize that 0.91 is decreasing, where X is the number of years after 2020. So these are like 20, here's 2005, 2010, 2015, 2020, okay? I'm sorry, no, 2020, 2025, 2030, 2040. Okay, doesn't matter. Honestly, it doesn't matter. So here's our model, and we need to graph this. So again, we want a table, and we want numbers that are going to fit inside this box that I have drawn for you, because again, the maximum number we can have is 3,000. So we're going to go to our calculator yet again. Y equals 3,000, parenthesis, point. Well, if you want, you could do 0.91, doesn't really matter. And then, do I have a decimal here? I gotta get rid of this decimal. 1 second. Shoot. Okay, there we go. And then we raise it to X. Now, again, you could graph it if you want. It's not really necessary because you're gonna plot the graph. But here is where you begin. Okay, 0, 3,000, 1, 2730, stuff like this. 2730. So we go here. We start plotting 0, 3,000, 1. So let's go to 5 because that's what we need. All right, so 5 is, I don't know, 1872. Looks good enough. Sorry. All right, so 5, something like this. Okay, so if you wanted to graph this, you'd have to change the window. It's not really worth it, but you could change the window. Let's go to 15 is 729. So 15 here, 729. So this thing's going to go like this. Okay? So, and you don't need to fill out the table. You just need to write it down. I didn't write it down. But anyway, here we go. Here's your graph. Okay? So you notice here, this thing kind of levels off, and it's going to go forever here. It's never going to touch. Oopsie, sorry. It's never going to touch this here. It's never going to actually touch it. It's just going to ride it along as it keeps going, because let's just say no, not everybody can move out of a town. All right, so let's get to the questions, and they're, again, pretty basic when you look at the graph. It says, what is the domain? Well, the domain is from left to right, and this is here, which is 0, and now I said this goes on forever, right? So this one's actually pretty easy. What you do is you don't have a compound inequality. You have that the x is literally going to go on forever to 0. So it's greater than or equal to 0, okay? The y, if you think about it, the y, if I go back, the y is here, right? So that's 0. This is the, oh, I don't have marking, hold on. Sorry about that. Here, let's do this. The y is here, right? This is y, right? Going up. There's nothing here, it's 0. And when does it stop? Well, as many people as there were living in the town. So 0 to 3,000. So that's what y is. So it's between 0 and 3,000. All right, I think that's all we need. What is the x-coordinate? Well, the x-coordinate doesn't exist. So you're just going to put an NA on it. Now, the x-coordinate doesn't exist because, as I said, sorry, it's never going to touch this line. It's exponential for a reason. It never touches it. So we never actually get, excuse me again, an x coordinate. All right. So we're just going to put NA. The y coordinate, when we look at the y coordinate, that we know is 0, 3,000. It says it right there, right? Right there. Oh, give me a little pen here. Right there, 0, 3,000. So that's what we're going to write. 0, oh, don't have my pen written. There we go. 0, 3,000. Okay. What is the minimum value? Well, we know that the minimum value is 0. And that's kind of, it's about 0, right? It's because it never does touch it, but it is 0 is our minimum value. And that's, what does it represent? It's no population. Okay. That's what it represents. What is the maximum? 3,000. What does that represent? Max people in town. And that's it. Sorry. Wow, that was really messy. I always end on a bad note, don't I? All right. People in town. Okay. So that's it. That's for what you need to do today for the 2 problems in the project. On Monday, whatever today is, so the next time we talk, you'll do the last 2 project points and get those to me as soon as possible so I can grade your project grade and get that into Tyler so that we can get our grades done. They're going to want to wrap this up as soon as possible. The last day you have is the 13th, okay? So you'll see then after that you're going to start taking your quote-unquote final exam that will only be counted as an assignment, all right? So don't freak out, but you're supposed to take it if you want this credit for the South Suburban College. Okay. All right. Let me know if you have any questions, and we'll talk later.